Hello and welcome back to Maths with Mr. Duffield. I am the aforementioned Mr. Duffield. Unfortunately today, I'm not going to work through a question so much as I'm going to explain the task that I've set for my UF set. This is one of the pieces of paper that you guys have been set on Teams. This is the second piece of paper, and then this is the third. Let me explain, because I've had a number of you requesting a more full and detailed explanation as to what's expected of you for this task. This is labelled the master grid, and what you can see here are a number of functions that have been drawn and labelled on the left, and then above them you should be able to see on the top of each column a number of functions. Now these need to be copied, onto the top of each transformation grid beside it. Okay, so what I'm suggesting is that for y equals f of x, each of these three boxes contain the following: y equals f of x plus 3, y equals f of x plus 3, and then the last one, y equals 3 f of x. Okay, there's not enough room for that last one, so I don't want you to worry about it. But for every single one of the functions on the sheet marked transformation of graphs 1 and transformations of graphs 2, I'd like that to be copied onto each graph. Then the task on both of these, transformation of graphs 1 and transformation of graphs 2 worksheet, is to draw the resulting function. Okay, I'll do the first one for you, just so that you can see what this kind of thing is about. But you should, if you've been listening to my lessons on transforming functions in previous weeks and months, you should be able to work out what would happen with these as well. But for f of x plus 3, each of the x ordinates, effectively x-intercepts, will be shifted up by 3. In fact, every single coordinate will be shifted up by 3. So the y-intercept goes from -2 to +1. That's 3 more. This 0, -1 point gets shifted up by 3. And this 0, 2 point here, 2, 0, excuse me, point, will be shifted up by 3 as well. Okay? If there are any other points that look particularly key, this lowest point here looks something like halfway between 0 and 1. That also gets shifted up by 3. 1, 2, maybe to about here as well. And then the rest of that is just grabbing a pencil and joining all these points together to make a nice smooth curve. Again, I'm not Pablo Picasso, so this might not look necessarily perfect. And indeed it doesn't. It's just a vague sketch. You can see that I've muffed it up a little bit there. That's okay. But effectively you can see this function is the function on the left shifted up by 3. Okay? Now we might look at the next function here, y equals f x plus 3. Of course we remember, don't we? If 3 is added to x, that actually translates as a shift to the left, the opposite direction to what we would expect. Plus 3 here is a shift up. And then for the y equals 3 f of x here, every y value of every coordinate in the function is tripled. Okay? So that's obviously going to have an impact not on the x-intercepts, because effectively for these x values, -1, y is still 0. So the x-intercepts are going to stay the same, -1 and 2. But every resulting y value is going to be tripled. In other words, by the time y becomes 1 here, it actually, for the 3x function, it's going to be tripled. 1, 2, 3. So it's going to end up here. And when y becomes 2, which is about here, it's going to triple all the way up to 6, which is up here. So there's almost a squishing inwards of the graph. But also, down here where y is -2, it triples all the way down to -6. So it will in fact look pretty steep. down like this, up like this, and then similarly on this side as well. Okay, so the function has been squeezed, effectively stretched in the y-axis direction. It gets longer in this direction and longer in the upwards direction as well. Okay, that is effectively the effect of adding 3 to that whole function, adding 3 to the x inputs, and then multiplying the entire function by 3. The y coordinates are tripled. All right, you're doing that process to y equals f of x when f of x is a quadratic. You can see this cubic. You can see this reverse cubic here, and then this one is a straightforward linear graph. All right, once that's finished, I do want you to, maybe, if you had the spare time and the inclination, have a look at this master sheet. You do the same thing. You can choose to do, if you wish, the same thing to these functions that have been labeled up. Okay, there's a couple of quadratics on one side, and then the cubic and the linear graph on the other side. And then if you wanted to consider f of 3x for this advanced section, I'll describe this as the trickiest element, then of course do have a go at that. I hope that explains a little bit more clearly what this task is and how we would go about doing it, particularly for the worksheet marked transformation of graphs 1 and transformation of graphs 2. Anyway, I wish you all the best with that work. Take care. I appreciate that my UF doesn't have a class this week. So what I will say as well is that I'm going to put on our shared Teams page a series of resources for your revision and review over the summer break, because when you come back in September, yeah, there's going to be an assessment for you. All right, so you've got to make sure that you're ready for it. I'll talk to you more about that on our Teams page, but for the meantime, take care. Good luck with this, and make sure it gets done. I will talk to you guys very soon.